let us do esters. Right, so with esters, they have a functional group COO, and this is how the structural formula of that functional group looks like. That's our COO there, that whole thing. Right, so and then for esters, another thing, the general formula is the same as the one that we had for carboxylic acids, which is CnH2n and O2. Right, so the reason for that, or part of the reasons for that, is because esters are generally made, or they are formed when the carboxylic acids react with alcohols. Right, so when that reaction happens, what we then form is a carboxylic acid. And then what ends up happening is the overall ester, or that compound that results from that reaction, will have a portion that comes from the alcohol and another portion that comes from the carboxylic acid to therefore form an ester. So we would be able to see this contribution of alcohols and carboxylic acids even in the final structural formula of the ester, right? So we'll be able to see that, oh, okay, because if you can check this functional group alone, I'm sure you've seen this whole part in carboxylic acids, right? So that's one thing about esters. And now, like I said, they form as a result of alcohols reacting with carboxylic acids, right? So when the carboxylic acids react with alcohols, that's how we form esters. And as a result, they will contain an alcohol portion and also a carboxylic acid portion. A good example is ethyl methanoate. So if you check, what we do is, this is what a normal ester would look like, right? That's whole compound. Then what we normally do is we go to where the O is, because the O is usually in the middle, and on the left of the O is there. In this case, on the left of the O will be the alcohol portion, and then on this other side of the O will be the carboxylic acid portion, right? So how do we know the carboxylic acid portion? Because if you remember, carboxylic acids have the functional group OH. Okay, so we go there and then we take out this part on the ester compound, and then anything that's either on the left or right of this part will be, so in this case we are taking this one, so we can see that anything on the left of this part will be belonging to the alcohol portion, and anything from this part going to the right will be belonging to the carboxylic acid portion. So what does that mean? It means initially we had an alcohol that was called, because this has 2, 1, 2, so this would have been ethanol, right, before they reacted with another carboxylic acid to form this ester, right? And then we have this one. This would have been, since it has 1 carbon atom, it would have been methanoic acid. Right, so now what happens is, once they combine, they then form what we are seeing here, which is ethyl methanoate. So we come here, we split the names. So what was ethanol would be ethyl, and then what was methanoic acid will be methanoate. Okay, so we'll do this properly once we start doing our naming rules and also our examples, but essentially that's what happens. So this we add together to form the final IUPAC name, which is ethyl methanoate. So essentially what we're doing is everything that is on this alcohol portion, we take it as an alkyl group. Hence, if you check, we named it ethyl, right? So initially it was ethanol, but now when it's participating in this, or when we check out the alcohol portion from this ester compound, we name that alcohol portion as if we were naming an alkyl group. Remember, with alkyl groups, you have your ethyl, methyl, propyl, and so on, depending on how many carbon atoms it has. So since this one had 2, it would have been we name it ethyl, right? Okay, so like I said, if you still don't get it, we will do the examples and then it will sink in. But that's essentially what happens with esters. And then lastly, they have a suffix as well, just like all the other compounds we've been doing. The suffix for esters is O8. Okay, which is this one, as you can see here. All right, so however, we will do examples and you shall see. All right, firstly, let's start by the naming rules. So when it comes to naming esters, the first thing that we do is we create an imaginary split between the carbon atom of the carbonyl group and the O atom, which is bonded to this carbonyl group. So what does that look like? Remember, the ester has a functional group that looks like this one, right? So that's our functional group. So what they're saying is we come here, we split it here, right? This is where we split it, and then anything on the side of the O is what would have been our alcohol, and we will name it the same way we would name an alkyl group. Like in the previous example I just showed you, this one was ethyl there, and then anything containing this part, that side, we will name it, let's see, anything containing that part on the left is what would have been our carboxylic acid, and therefore we would take, for instance, in this case, this carboxylic acid would have been methanoic acid. So what we do is we take that and then we remove the suffix oic acid, because remember that's the suffix for carboxylic acid, and we replace it with OATE, which is the suffix for esters. All right, and then at the end we then combine these two names, ethyl and methanoate, to form the name of the ester. All right, so that's what we mean. You split it there. So here, this side is the alcohol part, and then going that side would have been the carboxylic portion, carboxylic acid portion. Okay, so that's what we have. So now what do we do next? So the carbonyl group of the compound, like we said, is derived from the carboxylic acid, which is, the carbonyl group is the CO. So the left hand side, in this case, the left hand side of the split, and then the part where the O atom is bonded to is derived from the alcohol. So we treat the part that's bonded to the alcohol, to the O, because there will be a part that will be bonded here. It could be C, whatever, right? We treat that whole part as if it was an alkyl group, and then we name it the same way we would name an alkyl group, right? That part is what came from an alcohol. It was derived from the alcohol. So, and then number two, we start by naming the organic compound that is attached to, or the organic group that is attached to the O. So for instance, if we had C, and maybe C here, right? Something like this. We will start by naming these parts first, right? So if you check here, we have 3 carbon atoms, and if you remember, we said that 3, the stem name for any 3 carbon atoms in a chain is prop. So if we are naming an alkyl group, that would have been propyl, right? So we would name these parts as if we are naming an alkyl group. So that's propyl. All right, so of course the alcohol that was used to make this ester would have been propanol. All right, So we take that and we convert it to propyl. All right, so that's one thing you must remember. You name this part as if it's an alkyl group, and then we count the number of carbon atoms that are there, and from there we take a stem name, and also the suffix will be that of an alkyl group. Okay, so that's how it works with this part. That's part number one. Now, as you can see here, what was methanol becomes methyl, what was ethanol becomes ethyl, what was propanol, like in our case, becomes propyl, and etc. So secondly, you name the acidic part derived from the carboxylic acid by replacing the oic acid with OH. So remember, OAT is now the suffix that is used for all esters, right? So what that looks like is, let's say for instance this part had, let's change the color, let's say it had 1, like that, right? So if you count, this is 1, 2, 3, okay? And then also we had to count this side. This was 1, 2, 3 carbon atoms. So both sides have 3 carbon atoms. They won't always have 3 carbon atoms. This is just purely for exam purposes. I mean, for example purposes. Nothing. It's not to say that they will always have 3 on either side. All right. So now this would have been a 1, 2, 3, a propanoate. Propanoic acid, right? This was going to be propanoic acid, but now that it's in an ester, right, because this whole compound is an ester, we replace this anoic acid with, because it's like this, we replace this anoic acid, which was here anoic acid, we replace this with OAT. So now it just becomes propanoate. All right, propanoate. That's the suffix for esters. So now that we've done that, we then move ahead, and what we do is on the final name we start by the alcohol parts, which is propyl, and then the carboxylic acid, which is propanoate. So in this case, our full name or IUPAC name for the ester is going to be propyl propanoate. Okay, so that's what we have there. Okay, so this is how we would name esters in this video, or in general. All right, so again, we go to where the O is, we make a split there. Anything that's attached to the O, we name it as if we were naming an alkyl group. And if you remember, an alkyl group will always have YL as the suffix. So depending on how many carbon atoms it has, we will then take the stem name from our table. If it has 3 carbon atoms, like in this case, it would be prop, and then the suffix will be YL, so the full name becomes propyl. Okay, so once we're done with that part of the split, we'll go to the other one where there's the C, there's the double bond between the carbon atom and the oxygen. We look at that side again and we check that, oh, okay, in this case it has 3 carbon atoms, and this was initially a carboxylic acid, right? So what kind of carboxylic acid was this one? It was a propanoic acid, because it has 3 carbon atoms. So we replace the anoic acid with the suffix for esters, which is OATE, and therefore this becomes propanoate. All right, so in fact we can say, let's put it here, this went from propanoic acid to now what we have as propanoate. All right, So we replaced that anoic acid with O8. All right, so that's how we do it. So now if you notice, it means here, if you remember previously, what we would do is we would find the longest chain and start numbering from the side closest to the functional group. In this case, there's no need for that. In fact, on the other side of the O, we have our own numbering, and on the other side again we have our own numbering. So if you check for the alcohol part, we just have to go and count how many carbon atoms are there, whereas from this part, the carboxylic acid part or portion, we also have to count how many carbon atoms are there. So there's no such thing as, okay, let me number closest to the functional group here. All right, so you just have to split it and then count how many carbon atoms are there. And then same thing this side, you split it, you count how many carbon atoms are there. So this one will really have other substituents like your bromine, chlorine, and so on. But in cases where it does, you would have to also include those in the IUPAC name, okay? So for instance, if let's say there was some bromine atom here, right, we would have to account for that, okay? So let's check our examples to see how we would go about naming these ones. All right, so we have this one as our first example. So if you check, we do the same thing. We come where the oxygen is, we create a split there. All right, so what will happen is this will be the carboxylic acid part. No. All right, so so now we have the alcohol parts. So this would have been what? Check. 1, 2, right? So that would have been ethanol. All right, so since it has 2 carbon atoms and we must name it the same way we name an alkyl group, of course this would have been ethanol, right? But since now it's in an ester and we must name it as if it's an alkyl group or an alkyl substituent, any alkyl group that has 2 carbon atoms is called an ethyl. All right, so we said this is the alcohol portion. So, and then this one will be the carboxylic acid portion. Okay, so this carboxylic acid portion also has 2 carbon atoms, and for that reason it would have been an ethanoic acid, or it was an ethanoic acid, but now we'll replace that with O8, so it's an ethanoate. All right, so then we come and combine these two. We always start with the alcohol portion first, so we'll say the ethanoate is the name of the compound. So that's our answer. All right, so this is ethanoate. Sorry, that's the IUPAC name for this compound. All right, so this is the IUPAC name, ethyl ethanoate. Now let's check example number 2. Example number 2, again, we have to go to where the oxygen atom is and we split from there. So from here, we cut it here, right? In fact, let's take let's take this portion and come bring it here. So this would have been our alcohol portion. If you check, we cut it from here, it becomes our alcohol portion, right? And since it's the alcohol portion, an alcohol that has 3 carbon atoms would have been propanol, right? So since we have to name it as if we're naming an alkyl group in this case, that propanol becomes propyl, right? So this would have been propanol, but we will call it a propyl, right? So I must create a note here to say we name the alcohol portion the same way we would name an alkyl group. Okay, so we name the alcohol portion the same as we would name an alkyl group. All right, always. Now this means here we have propyl. Okay, so why is it propyl? Again, remember it has 3 carbon atoms, 1, 2, 3. Okay, then we come again and create another split. So the other remaining parts will be the carboxylic acid portion. This would have been the carboxylic acid portion. So this carboxylic acid has 1, 2 carbon atoms. So this is an eth. The stem name is an eth, and since now we are on carboxylic acids, we move it from ethanoic acid, and then we said we are replacing this part, and then now it becomes an ethanoate. All right, and then at the end we combine these two names, so it's propyl, the alcohol portion, plus ethanoate, which comes from the carboxylic acid portion, and then this gives us our IUPAC name, ethyl ethanoate. So that's our IUPAC name. Okay, so like we said, it's simply the alcohol portion, and remember this is on the rules to naming carboxylic acids plus the carboxylic acid portion. And then of course portion has a, all right, so that's what we have. We have the carboxylic acid portion plus the alcohol portion to then get the final IUPAC name. Okay, so this is how it works. All right, so it's actually almost the same thing over and over again. We just name it like this, and for all the other carboxylic acids, unless of course there's something else that we need to take into account. Like for instance, if we have another substituent like a methyl group, or say we have a halogen atom, Okay, so that in that case you would have to account for those as well. So here's another example. Now here we are given a condensed structural formula, and we must still do the same thing. We must find the alcohol portion and find the carboxylic acid portion, and then name this final ester, or name this ester compound accordingly. All right, so let's do that. Let's start with the alcohol portion. So anything from here we split, remember, to the right side of the oxygen atom is our alcohol portion. All right, so this is the alcohol part. And then if we check how many carbon atoms are here, we have 1, 2, 3, 4, 5. Okay, so this would have been pentanol, but we will call it pentyl, okay, because it has 5. We'll name it the same way we would name an alkyl group. Always remember that. Now we are left with the carboxylic acid part here. All right. So this carboxylic acid portion has 2 carbon atoms, 1, or let's just say 1, 2. Okay, so for that reason, this would have been, or this is an ethanoate. It was ethanoic acid, but we replaced the anoic acid with OATE, so this becomes an ethanoate. And again, we take pentyl, so we take our pentyl, right, we add it with the name that we derive from the ethanoic, the name that we derive from the carboxylic acid portion, and then finally we get that this should be pentyl ethanoate. We always start the IUPAC name with the alcohol portion followed by the carboxylic acid portion. So this is our final IUPAC name. All right, so that's how you would do this carboxylic acid. Now let's go to another example. Example 4. All right, so in this example, we do the same thing again. We find our alcohol portion. Of course, you can always start with the carboxylic acid portion. It doesn't really matter because it's something that you do on the side or in your mind. The more you practice, you won't even need to draw these boxes that I'm drawing. These are for you to see, right? So this is our alcohol portion. Okay. And then this would be our carboxylic acid portion. Okay. So all right, so carboxylic acid portion, remember what was once a carboxylic acid of, let me see, 1, 2, 3, 4 carbon atoms, which this would have been a butanoic acid, remember, or this was a butanoic acid. And now we must replace that anoic acid with OATE, which is the suffix for esters. So this will be butanoate. All right, OATE from the anoic acid. All right, so the alcohol portion, this was, let's see how many carbon atoms we have there. 1, 2, 3, 4. So this was butanol. All right, and then since we must name it the same way we name alkyl groups, we will call it butyl. Okay, that's our new thing there. Then we take, of course, butyl plus butanoate to get our final IUPAC name. Alright, and then this gives us our final IUPAC name, which is butyl butanoate. So that's our final IUPAC name. For this organic compound, for this ester. Alright, so that's one thing you must note. And then now let's check our other example. Here we are told to draw the structural formula for this ester. So how would we know it's an ester? Because if we check, it ends with OATE. Because you can be faced with an issue where now you're given multiple organic compounds, and then perhaps you're asked to draw the structural formula for each, right? So you'd have to check their suffixes, right? So this is a giveaway. This is definitely an ester. Another way you can see this, it says propyl, but there is no number to it. Usually if we are including an alkyl group in the name of a compound, it usually has a number because we want to know where along the carbon chain is it located. But in the case of esters, we usually don't have that number, so we know for sure that this is an ester, right? That's just a side tip. So we know that this ester has the length of the alcohol portion. The length of the chain in the alcohol portion is 3, right? Right, so that's the length of the carbon chain in the alcohol portion. And then this one gives us the length of the carbon chain in the carboxylic acid portion. All right, so that's what we have. So now we can start drawing the structural formula. Okay, let's start with the alcohol portion. We can say come on. So we can say that we have 1, 2, 3, right? And then there'll be that O there because we said we split it somewhere here. Actually, we split it on the other side. We split it here, right? So we know that on the other side of the O, we will have 3 carbon atoms for the alcohol portion. So we can put our H's. Okay, so now let's put the carboxylic acid portion. So we'll have that C there. Then we will have, since they said it's butanoate, which means there's 3 more carbon atoms here. 1, 2, 3. So in total it's for 1, 2, 3, 4. Okay. Then we can start putting in our hydrogen atoms. And that's this. All right, then that does it for our structural formula for this particular ester. All right, so this is how you would do an example or a problem like this one. Okay, so that's all the examples, and then we have this last one. That's example number 6. All right, so here again we have this portion being the length of the carboxylic acid portion, the length of the carbon chain in the carboxylic acid portion. And then we have this one being the length of the, let's use the hex, being the length of the carbon chain in the alcohol portion. Okay, so that's what we have. Okay, so that's what we have. Now let's start drawing these things. So the carbon chain of the alcohol portion has hex, which is 6 carbon atoms. So we can say 1, 2, 3, 4, 5, 6. Okay, that's 6. Then we put our O there to have that. And then now let's add our hydrogen atoms. So we have H, right? So hex 1, 2, 3, 4, 5, 6. And then on the other hand, we had ethanoate. So ethanoate has 2. Eth is 2. So let's first add that, our carboxylic acid portion. The carbonyl group starts first, of course, and then now since it has 2 carbon atoms according to the name, then this is the last one. We have H, H. So that does it for this one as well. So this is how we would draw the structural formula for this specific carboxylic acid. Okay, so we've done pretty much all the basics and all the fundamentals of what you would necessarily need to know in order to be able to deal with esters as organic compounds. And then we will continue and focus on other organic compounds. So that does it for this video, and I'll catch you on the next one. Cheers.